Now let's test the game. So I have two devices here. In the first one, I will create a group. So let's put my first group and I will create the group. Now in the next device, I will click join group and here I will put my name and I will put the group code, that is K2K So I have K2K. Now from this device, I will continue to game. It will ask me to select a word. So let's select ghost. And here I will click join group. And then again continue to game. Now from here I can type the guesses. Let's say GHOS or whatever your guess is. From here I can see the guesses and this player will draw this word. So here I need to draw a ghost. So let's draw it. Ooh. And here you can see we have the ghost. And if I enter the correct word, that is ghost, I get congratulations, Belal has the correct answer. So this is our game and it is working absolutely fine. Hi everyone, my name is Belal Khan and I am a developer advocate at Stream. In this video, we are going to build a complete game using Stream SDK. So it is a multiplayer party game where one person will be given a random word and then the person will draw that word and other participants needs to guess that word and whoever guesses the right word wins. So it is going to be a very big project and we will do everything step by step. And we are going to use Stream SDK for the chat feature of this application. So let's start. As always, first we need to create a new project. And I have created a new Android Studio project here with the template empty compose activity because in this course I will be using Jetpack Compose for the UI. You can see here I have already added all the required dependencies in my build.gradle file. So I need to open this build.gradle file, that is the app level build.gradle file. And here you can see I have added Jetpack Compose sketchbook, that is a library made by my friend Jayvoom, and we are going to use this sketchbook for the drawing area of the application. Then I have added Stream Chat Compose SDK because it is required for the chat feature. Then I have added Retrofit for network calls and Moshi for Retrofit Converter Factory. And this time we are going to use dependency injection and that is why I have also added HILT. So all the dependencies are set up already. And I have also created some composable components that I will use to design the UI. But you do not need to worry, you can get the source code of the full project from the link that is given in the description of this video. Now coming back to the project, I will create two activities for this project. The first one is the main activity, and in this activity we will handle three things. The first one is the splash screen, where we will show two buttons for creating group and for joining group. Next, we will have separate UIs for create and join group. Once the group is created or joined successfully, we will move to the next activity, that is game activity. Now let's begin with designing the splash screen. So I will close all the open files and from here I will change the mode to Android. And inside the UI package, I will create one more package. So inside UI we have components and theme. I will define one more package and I will name it main. Inside main we can create splash. So I will define a Kotlin file class and I will name it splash. Now it is a composable function. So we have @composable and then fun splash. Now inside this screen, I will create a constraint layout, and inside constraint layout, I will create a vertical column, and inside the column, I will create two buttons to join and create group. Because we are going to design UI, we also need to see the preview, and that is why first let's define the preview function. So we have preview and then composable, and we can name a default preview like this and splash. Now we can see the preview here, as you can see. Cool. Now let's define the splash. So first I will create a constraint layout. So here you can see how to use constraint layout with Jetpack Compose. So for the constraint layout, I will pass a modifier, that is modifier.fill max size like this. Now inside constraint layout, I will define a linear layout, that is vertical, or you can say I will define a column because it is similar to vertical linear layout. And if you want horizontal, you can use row. So we have column. Inside this column, I will define two buttons. So I already have defined some composable components. The first one is primary button. For the text, I will pass create group. So one more thing that I have already done, and it is defining all the strings that are required, as you can see. So I can use the string for create group. Again, you can get the source code, so no need to worry. So here I will pass string resource and I will pass the ID, that is r.string.create group. Let's import R. So we have a primary button. If I build and refresh, you can see we have the create group button. The same way, I will define a secondary button, and this is string resource. And here to the primary button, I will set margin bottom, that is, let's say 16 dp. Now, if I build and refresh, you can see two buttons here. Now I need to set the constraint to make the buttons at the bottom. So to set constraints to this column, because this column is the view group for these two buttons, and I will set the constraints to this column. So first we need to define a constraint layout reference. So I will write here val column equals to create ref. We use this function to create reference for constraint layout. Now to the column, I will pass a modifier. So we have modifier equals to modifier. And the function that we need to use is constraint as. Here we will pass the constraint reference, that is column, and a trailing lambda. And inside the trailing lambda, we will set all the constraints. So we will get 4 constraints for top and bottom and for left and right. For top, it is top, but here we need to worry about bottom because we need to constrain it to the bottom. So I will use bottom and I will link it to parent bottom like this. Then I will use start, that is for left, and I will link it to parent start. Then I will also use end, that is for right, and I will link it to parent dot end. And I can also set some margins. For example, for bottom, I want a margin of 64 dp. For start, I want 16 dp, and for end also I want 16 dp. Now, because I want this column to fill the available constraint, I will use width as dimension dot fill to constraints. Now, if I build and refresh the preview, then you will see all the constraints are set and these two buttons will go to the bottom, as you can see here. So our splash screen is ready. Now from splash, the user will go to either create group or join group. So let's start with create group. And now I will design a create group form. So inside my project, I will create a new Kotlin file and I will name it create group form. And actually I will create a new package and I will name it group. And inside this package, I will create a new file that is create group form. And here we will define a composable function. So we have fun create group form like this. And because I want to see the preview, I will define preview and then fun default preview, and it should also be a composable function. So let's write composable here, and I will preview create group form like this. Now I will close this and I will make the design to split so that we can easily see the preview. Now again, here we can define a constraint layout like this, and inside the layout we can define a column to create vertical elements, or you can consider it as a vertical linear layout. Now again, I will create a column reference here, that is create ref, and I will set the modifier to the column. So we have modifier equals to modifier dot constraint as, then column, and then the trailing lambda. Import the modifier, and that's it. Now we will set the constraints. So we will start with top and we will link it to top, that is from parent. So we have parent.top here, then bottom, link to parent.bottom, the same way start and end. If you want, you can set some margins here. Now designing is up to you. I am not focusing much on designing because it will take a lot of time and it may make this content boring. So I'm just quickly designing anything that I see is good. So we have the column, and inside column we will define some text input fields. And here inside my project I have created some components, and here you can see I already have designed this app text field that I will use to design my create group form. So let's do it very quickly. So here you can see we have created the form for create group. So when we want to create a group, we will add the name, the maximum number of users, and the time that we want to limit for a particular drawing. So our composable create group form is ready. And now when the group is successfully created, we will display a bottom sheet, and inside that sheet we will display the group unique code that others can use to join that group. So now let's create a bottom sheet for the case when the group is created. So I will create one more Kotlin file and I will name it group bottom sheet. Now inside this file we will define our bottom sheet. Now first define a composable function because we just need to play with the composables. So we have the function, let's say group bottom sheet. Now whenever we want to display a bottom sheet, we need few things. The first one is bottom sheet scaffold state. So we will pass this as a parameter. Now it comes inside the experimental API, so we need to add this annotation to remove some compilation error. Now after this we will pass a flag and let's name it expand. Now it is a boolean flag, and whenever it is true we will expand the bottom sheet. Now after this we need two more composable functions here, and the first one is the bottom sheet content. So I will define sheet content and it will be another composable function like this. And we also need the main content, and it is also a composable function. Now inside this function, that is group bottom sheet, I will define bottom sheet scaffold, and with the help of this scaffold we can display a bottom sheet. Now it takes some parameters. The first one is the sheet content that we already have in this function. So for this sheet content we will pass a lambda, and inside the lambda we will call our actual sheet content, and it will render the sheet content like this. Now with sheet content we need some other values as well, that is scaffold state, and we will pass the bottom sheet scaffold state from here. And we have the sheet content already. We will define one more value, that is peak height, and let's make it 12 dp or whatever height whatever peak height you want for your bottom sheet. You can play with these values. So we have the bottom sheet scaffold, and inside this trailing lambda, we will pass the main content for the sheet. And inside this trailing lambda, we will pass our main content. Now the work for the bottom sheet is ready, but we also want to expand the sheet whenever this expand flag is true. So we will check two things. If this expand is true and the sheet is not already expanded. For this, we can use bottom sheet scaffold state, and from here we will get the state and we will check if the state is collapsed. So if the state is collapsed, we will expand the state. So here we will write bottom sheet scaffold state dot bottom sheet state dot expand. Now this expand is a suspending function and we need a coroutine scope to call this function. Now to use a coroutine scope inside a composable function, what we can do is we can use the function that is launched effect. And to this function we can pass bottom sheet scaffold state dot bottom sheet state and then a trailing lambda. Now inside trailing lambda we have the coroutine scope, and inside this scope we can call expand. So now our group bottom sheet is ready. One more thing that we need to create is to render our group bottom sheet and create group form. So I will create one more Kotlin file here and I will name it create group. Now it is again our composable function and we have fun create group like this. Now inside this composable function we will call our group bottom sheet, and for this group bottom sheet the first thing that we need to pass is this bottom sheet scaffold state. So first here we will write val bottom sheet scaffold state equals to, remember, bottom sheet scaffold state like this. And because it is an experimental API, we need to add this annotation as well. So we have the bottom sheet scaffold state that we can pass here. Then we want to pass expand, and for now I will pass it as false, and later we will add the logics when we are done with UI designing. Now for sheet content, we will pass the sheet content, and I just realized that I have not designed the sheet content. So before moving ahead, let's design the sheet content. So inside the package group, I will create a new Kotlin file class and I will name it group entrance sheet content. Now let's quickly design our entrance sheet content. Now here you can see we have designed the sheet content. So this is our sheet content that we will show to the user that, hey, this is the group code and other people can use this group code to join this group. So this is a very simple design, and again I am telling you that you can get the source code from the link that is given in the description of this video. So now let's go back to our create group file. Now here for the sheet content we can call the composable that we just created, and for the main content we can pass our create group form. Now for our main activity we need to create the last thing, that is join group. So again I will create one more composable function inside a new file and I will name it join group, and again I will quickly do the designing. Now here you can see we have our join group form ready and we can use this form to join an existing group. So all the screens that are required for our main activity is ready, and now we can club all these screens in a navigation host. And for this I will create a new Kotlin file inside the group package only, or I think I will create it inside main. So here I will create a new Kotlin file and I will name it main screen. Now it is a composable function and we have one main screen like this. Now here we will call another composable function, that is nav host. And you can see to call a nav host, we need the nav host controller. So we will be using this function, that is nav controller and start destination. So first let's define nav host controller. So we will define nav controller here and it is equals to, remember, nav controller like this. So we have the nav controller. Now we will call nav host and here we can pass nav controller and we can pass the start destination here. So for start destination we can pass a string for now, and after that we need to pass a trailing lambda, that is our nav graph builder. Now before defining the navigation graph, I will create one more file to define all the navigation routes. So inside the main package, or I think inside the UI package, we can create a new package and we can name it nav. Inside nav, we can create a Kotlin file class and we can name it navigation. And here I will just define 3 constants for now. So we have the navigation routes ready. Now come back to main screen and here for the start destination we will pass nav splash. So this is our start destination. Now we will add all the composables inside this nav graph builder. And to do this we can use the function composable. So we have composable, here we will pass the route. So first we will start with nav splash and after the route we will pass a trailing lambda and here we will call the actual composable function. And for splash we have splash, and the same way we will call create group and join group. So now we have our navigation host ready. Now let's go to main activity and here we can set content and then our main screen. Now we can run the application and see whether our splash screen is coming or not. So let's run it. So you can see we have create group and join group. So the UI design is completed for our main activity. Now we need to navigate to create group when we will click on this button, and the same thing we need to do for join group. And when we are at create or join group, we need to actually create a group and we need to actually join a group. So now let's start coding the create group part. Let's again open the splash screen. And here we need to open create group screen when this button is clicked and join group screen when this button is clicked. And because we need to navigate to different places, we need the nav controller. And that is why to this function splash, I will pass nav controller. So here I will write nav controller of type nav controller. And with the help of this nav controller, I can navigate between different places in this activity. So first, I will write an on click for this primary button. So I can write here on click, and whenever I will click on this button, I want to navigate. So I will put the parameters on separate lines so that you can see it clearly. So for on click, I will write nav controller dot navigate and then nav create group. And the same way for this secondary button, we will navigate to join group. So this is how we navigate using nav controller. But now this function splash expects a parameter, and that is why I am having a compilation error here. So what I can do here is I can call the function that is remember nav controller like this, and where we created the main screen. So open this main screen file, and here also we need to pass the nav controller, and we already have the nav controller here. So I just need to write nav controller like this, and everything else is fine. Now let's run it again to see whether it is working or not. So this is our application. Now let's click on create group, and you can see we have our create group form. And if I go back and click join group, then we have our join group form, and the text color is white here. I need to change it to black, so we will do it, but for now it is working absolutely fine. Now let's go to create group. So this is our create group form, and here we have display name, limit user, and limit time. And whenever this button is clicked, that means here it is the on click of this primary button. So here we need to create a group. Now to create the group, we need to create a channel in the stream. So in stream, we can create channels that multiple people can join for chatting. So I am going to use the streams channel for this games group. Now to create a channel in stream, we need to initialize stream SDK. So I already have added the API key in my strings.xml file, but in your case, you need to go to getstream.io and you need to sign up for a trial account. And from there, you can get your API key and API secret that you need to build this project further. So I hope you already have it, and now we can move ahead. So to initialize the Stream SDK, I will create an application class. So here inside my main package, I will create a new Kotlin class file, and I will name it Stream Draw Application. Now because I want to make it the application class, I need to extend or inherit application here like this. And inside on create, that means whenever the application is created, I will initialize the Stream SDK. And because I am going to use dependency injection with Hilt, I will also mark this class as Hilt Android app, because this is needed when you want to use dependency injection with Hilt in your Android project. So now let's initialize our Stream SDK. For using Streams SDK, we have two classes that we need to initialize first. The first one is chat client. So I will create a val here. So we have val chat client. The type would be chat client. And let's import this class. Now it is equals to chat client dot builder, and then we will set the log level. So we have the function log level to set the log level because we want to see the logs when we are developing an application. And then finally we can call build to build this chat client. Now to the builder, we need to pass some parameters. The first parameter that we need to pass is the API key. It is very important. And to get the API key, you need to sign up at getstream.io. So here I can write getString to get the string from strings.xml. And the string that I need is r.string.api key, that is stream API key. And the next parameter that I need to pass is the application context. So I can pass this here because I am inside the application class. Now for the log level, I will define one more val. So I have val log level equals to if build config.debug. If the application is in debug mode, I will set the log level. And for setting the log level, the level that I need is chat log level dot all. And in any other case, I will take chat log level dot nothing. That means if we are inside debug mode, get all the logs, else get nothing. So I will set this log level here like this. So now we have our chat client. Now with the help of this chat client, we can initialize chat domain. That is also required for initializing our Stream SDK. So here I will use chat domain, and this is our chat domain. Then we can use the builder instance and we can call some functions here. But first we need to pass some parameters. And the first parameter is the chat client that we already have. So I will pass the chat client here. And for the next parameter, we need the context. And because we are inside an application class, we can pass this. Now finally, we will call build to build the chat domain. And before building it, you can also use some functions. For example, I want to make it offline enabled. So I will call this function to enable the offline features of Stream SDK. And then finally, we can build our chat domain like this. So now we have initialized the Stream SDK. And to finish this thing, we need to add this class to manifest file. So I will open Android manifest.xml, and here I will pass name and then StreamDraw application, the class that we created. Now our Stream SDK is initialized and we can use it to create our channel. But the next problem is to create a channel using Stream SDK. The first thing that we need is we need a user. But in our application, we are not having any kind of user authentication. So what we will do is we will create a user with a random user ID. And to generate random IDs, I will create a function. So I will create one more package in my main package and I will name it utils. Inside utils, I will create a Kotlin file class and let's name it commons. Now here I will create a function that is private fun generate unique ID. This function will return a string that is of course the ID. Now how do I generate a unique ID in Kotlin? So I need some parameters. The first parameter is the length. So the length of the ID, so it would be an integer. We don't write vals for function parameters, so it is just length of type int. The next parameter that I need is allowed chars, and it is of type list of type char. Now we will use this list of allowed chars to generate a random sequence of characters, and finally we will return that as a string. And to do this, what I can do is I can return a range from 1 to length, and then I can map it, and inside map I will get allowed chars dot random. I'll get random items from this allowed chars list, and then finally I will call the function that is join to string. You can pass a separator, and for separator I am passing an empty string because I do not want a separator in between, but I want just a random string without spaces or any separator. Now I can use this function to generate a user ID. So I will define one more function that is generate user ID, and it will also return a string. So here I will write return generate unique ID. For the user ID, I want the length as 8, and allowed chars, for allowed chars we can pass caps A to Z. We are passing ranges, and then I will add small a to small z, and then one more we can pass that is 0 to 9. And here in place of plus I need to pass double dot, that means range. And here I have written generate user ID that will go inside an infinite recursive call. I need to call this function here, that is generate unique ID. And that's it. But I think I need to put 0 and 9 as chars because it is not a number range but the character range. So that's it. Now we can use this function, that is generate user ID, to generate a unique user ID. Now how do I test this function and make sure it is working fine? So what we can do is, in Android, we can write a test case to see it is working or not, or we can use a scratch file. So press the shift key 2 times and you will get this window, and here you need to type scratch and select this option, that is scratch file. And here you need to create a Kotlin scratch file. So I will select Kotlin, and now we have this window where we can write the code. So first we will select the module, that is Stream Draw app, and I will select this module and I will mark this option, that means make module before run. And now here I can generate a unique ID. So I will write here val user ID equals to generate user ID, and let's print this ID. So I have println user ID, and let's check if it is working or not. So we can simply run it, and here you can see we have the random ID for the user. That means our function is working absolutely fine. So let's go back to commons. I will close the scratch file, and after generating the user ID, I also need group ID that we will use as our stream's channel ID. So I will define one more function here and I will name it generate group ID. It will also return a string. So I can simply copy this line from here to here, and this time I will generate a random ID of length 6, and this time I need just A to Z and 0 to 9, and I will remove this thing from here, and that's it. Now we have two functions to generate user ID and generate group ID. Now let's go back to our UI. Now let's go back to our create group form. So it is inside main, and inside group we have create group form. Now whenever we will click on this create group button, we will take the inputs from these input fields that we are taking already. We have three variables here: display name, limit user, and limit time, and we will use these values to create a new group. But the logic for creating a group, we will not put it here, but we will put it inside a view model. So now we will create a view model. So inside the main package, I will create a new Kotlin class file and I will name it MainViewModel, like this. So we have this class MainViewModel, and because it is a view model, we need to extend view model to this class. And as I told you that I am going to use dependency injection in this project using hilt. So whenever we are creating a view model and we want to inject that view model, we need to annotate that view model class with hilt view model, like this. And after annotating the class with hilt view model, we also need to use the annotation that is inject. That means we want to inject this class. So here I will write inject and then constructor, like this. And we will import this inject. Now inside constructor, for now, I need the chat client, because with the help of chat client, we will create a channel that will act as our games group. So here I will pass private val chat client of type chat client. Now because we need to inject this class that is MainViewModel, and we are doing a constructor injection, but to build this class, we need this chat client that the compiler don't know from where to get. And that is why we will create a module that will give this required dependency. So inside my main package, I will create one more package and I will name it DI. Inside DI, I will create a module and it is stream module. You can name it anything that you want. Now, whenever you are creating a module, you need to use object and not class. And you also need to annotate it with module. And because we are using health, we need install in annotation as well. So we will write install in and then singleton component class like this. Now here I will define two functions, and for each function I will use the annotation provides and then singleton because I want the single instance, and then I will define a function as fun provide chat client, and it will provide the chat client. Because we have already initialized the chat client, so we just need to use chat client.instance to get the chat client instance. And the same way I will define one more, that is provide chat domain, and this time I will use chat domain dot instance like this. Now we have a module that will provide the dependency that is required for this MainViewModel, and now we can create a channel using this chat client. Now inside our view model, first we will define a private val user ID, and it is of type string. Now for the getter of this property, I will use generate user ID. But now every time I will access this user ID, it will generate a new user ID. So to fix this situation, once a user ID is generated, we will save it to shared preferences. And before generating a new user ID, first we will check if an ID is already saved or not. In case it is not saved, then only we will generate the user ID. Else we will use the saved user ID. Now to save this user ID, let's create shared preferences. So what I will do is I will create a new class, and for this inside my main package, I will create a new package and I will name it data. Inside data, let's create a new Kotlin class file and we can name it app preferences like this. Now again, I will use the constructor injection for this app preferences. So I will write inject constructor like this, and inside this class, I will define a companion object, and here I will define the preferences name first. So we have private const val shared pref name. For the name, let's say we have stream draw prefs. Now I need to save user ID. So here I will define private const val key user ID, that is key user ID. Now I can use this key to save the generated user ID. Now let's create a shared preferences instance where we can save our user ID. So I will define private val shared preferences of type shared preferences like this. And now to initialize the shared preferences, we need context. And for context, I will pass it to the constructor. So here I will write context of type context. Now I can use the context dot get shared preferences. For the first parameter, I'll pass the name that I just defined. And for the mode, I will write context dot mode private. Now we have the shared preferences instance, and we can use it to save the user ID to shared preferences. So let's define a var user ID of type string, and for the getter, I will define shared preferences dot get string. For the key, I will pass key user ID, and for the default value, I will pass null. And because the default value is null, we need to make the string as nullable like this. Now for the setter, I will write shared preferences dot edit. To save a value, we need to use this edit function. This gives the editor, and in the editor we can use put data type function. In this case, we need to use put string because we want to save a string. So for the key, I will pass key user ID, and for the value, I will pass value. And finally, I will call apply. Now with the help of this property, that is user ID, we can save the user ID to shared preferences. Now let's go back to MainViewModel. And here before generating the user ID, first we will check if the ID is already available in preferences or not. And to check it, we need the app preferences instance. And that is why I will define one more parameter for my view model, that is private val preferences of type app preferences, like this. Now instead of generating the user ID with the help of this function, what I will do is I will get the ID from the preferences first. So I will write here prefs.userid. If it is null, I will generate the user ID using the function, that is generate user ID. And once the user ID is generated, I will save it to preferences. So I am using the also function here. So also prefs.userid equals to it. Now if the user ID is available, we will get it. If not, we will generate the ID and save it to preferences. So we have the user ID. Now we need to create a function that we will use to connect the user to stream. So let's define a private fun connect user, and to this function we will pass the display name of the user. So we have display name of type string. Now here first we will check if a user is already connected or not. So here I will write if chat client dot get current user is not equals to null. It means a user is already connected. In this case, I will call chat client.disconnect to disconnect the existing user. Now after this, we will create a user instance from streams user class. So I will define a user of type user, and we need to use this one, that is from stream models. So we have user. For the ID, we will pass ID equals to user ID. And we will pass some extra data, that is map of, and here we need to pass keys and values. So let's say we have key name to display name, and you can pass all the other parameters that you need for your user. For this case, just name is enough. And we are getting some error here, and it says required is mutable map, but we are passing map. So instead of this map, we can pass here mutable map of, like this. And instead of passing this hard-coded string, I will pass a constant, that is key name. In this project, we will be needing a lot of constants. So to save all the constants in a proper place, I will create one more file and I will name it constants, and inside this file I will save the constant that I just created. So we have key name, and I can use key name like this. Now let's import the constant. So we have the user instance ready. Now we can use this user instance to connect to stream, and to connect this user to stream we can use the chat client instance. So we will write chat client dot connect user. For the first parameter, we can pass user, and for the next parameter, we need to pass either a token provider or a token. Because I do not want to involve backend in this project, and this is also an example project, a sample project, I can use the dev token to bypass the token authentication. But remember, you should not use this method in your production applications. So first I will generate a token. So I have token equals to chat client dot dev token. And to generate a dev token, we need to pass user ID that we already generated. Now I can pass this token here. And now we are connecting this user to the streams backend. But to complete this process, we need to call either enqueue or await. Because I want to avoid the callbacks, I will use await. And because I am using await, I need to mark my function as suspending. So we have private suspend fun connect user, and here we are connecting the user. Now finally we can return the result. So let's change the result type. And whenever we will call this function, we will get the connection data. If the connection is successful, we can move ahead and create a channel, that is our game group. If the connection is failed, we can show an error message to the user. Now after connect user, we will define one more private suspending function, and this function will create a channel and stream. So let's define private suspend fun and create channel. To this function, we will pass some parameters. The first one is again display name, that is of type string. Then we have limit user, it is of type int, and number of rounds of type int. And one more thing that we need is the channel ID or group ID. So we will pass group ID as string. Now inside this function, we will create a channel, and to create the channel, again we can use the chat client instance. So we have chat client dot create channel. Now for the first parameter, we will pass the channel type. So we are going to create a channel of type messaging. For the channel ID, we will use group ID, and for members, we will pass a list of user IDs, and for now we will pass list of the current user ID. That means this channel has only one member, and the member is who is creating the channel. So later when other people will join this channel, we will update the list of members. But for now, there is only one member who created the channel. Now again we will pass extra data for this channel, and again we can use mutable map of, and here we can put all the other information that we want for our channel. So first we will pass key name to, let's say we have display name and then apostrophe s and group, that means names group. Then we have key limit user to limit user. Then we have key number of rounds to number of rounds. So we have added all the extra data that we need. But I think we need one more thing, and that is host name. So who is creating the channel is the host of this game. So I will use one more key, that is key host name to display name. That's it. And again we will call await to perform this action, and we will return the result. So let's write the return type. So now we have the result here. Now with the help of this function, we can create a group. Now finally we will create the function that we will access from outside this view model, and this function will create the group, or we will call this function when we will click the create group button. So I will define fun create group, and I will use view model scope for this function because I am going to call some suspending functions. Now to this function we will pass the inputs. So first one is display name, that is of type string. Then we have limit user of type int and number of rounds of type int. And I think I will name the function as create game group. So that's it. Now here first we will connect the user. So let's write val connection equals to connect user. We will pass the display name, and now we will check if the connection is successful. So if the connection is a success, we will create the game group. So here we will generate the group ID first. So we already have a function defined to generate the group ID. So I will write group ID equals to generate group ID. Now we have the group ID. So we can call this function to create the channel. So I will call val channel equals to create channel. We will pass the group ID, then the display name, then limit user and number of rounds. To make it more readable, we can add the names to the arguments like this. So we have created a channel as well. Now after this, we will check if the channel creation is success. That means our group is created and we can move ahead, and else we have some kind of error that we can show to the user. Now from here we can emit the information that we have, whether the channel is created or we have some kind of error. Now to wrap this information, we will create a sealed class. So go again to your data directory, and here we will create a new Kotlin class file and we will name it game connection state. Inside this file, we will create a sealed class that is game connection state, and inside the sealed class, we will define all the possibilities. So the first possibility is none, and it will extend game connection state. Then we may have a loading state. Now we can have a success, that is success, and when we have the success, we will receive the channel that is created. So we have channel here, channel of type channel, and we need to use the channel from stream. So make sure you are using this channel. And the last case would be failure. And for failure, we can have chat error of type chat error. And this will also extend game connection state. So we have 4 possibilities of our game connection state. So all the possibilities you can define inside a sealed class, and we can emit the information from ViewModel using this sealed class. So let's go back to MainViewModel, and here at the top I will define a state flow. So I will define a private val game connection state, and it is equals to mutable state flow, and the initial value would be game connection state dot none. That means empty. For the type, we can define here game connection state like this. Now it is mutable and I can change its value, but I will do it inside this ViewModel only, and that is why I have defined it as private. Now to observe it outside the ViewModel, I will define a val that is game connection state, and I will make its type as state flow. This is immutable, and for the getter I will write game connection state like this. Now I also need to define the type that is game connection state here, and that's it. Now at the bottom inside my function that is create game group, I will write here when the connection is success, so game connection state dot emit, and I will emit the value that is game connection state dot loading. Then here when the channel is successfully created, I will write game connection state dot emit, and then game connection state dot success. And for success we need to pass channel, and we will get the channel from this channel. So here we will write channel that is result dot data, and we will get the channel here. Now in case of a failure, we will write game connection state dot emit, and then game connection state dot failure like this, and we will get the failure using channel dot error, and we will get the chat error. Now that's it, and we can call this function from our create group form. Now to call this function we need the ViewModel, so we can pass the ViewModel here to our create group form. So here I will write ViewModel of type MainViewModel like this, and now with the help of ViewModel I can call the function that we just created. So we will write ViewModel dot create game group. We can pass the display name that we already have here, then limit user and number of rounds. What is the third value? It is limit time. Actually, we don't have number of rounds, but we have limit time. So I will rename everything to limit time. So it is limit time. Here also limit time. And here also it is limit time and not number of rounds. So we have limit time and limit time here. And I will rename this constant as well. So we have refactor, rename, and it is key limit time. And that's it. Here also it is limit time. So it is fine here. Now let's go back to create group form. It is also fine here. Just in the preview function, we need to pass the view model. So for now, I will just delete the preview function and the error is gone. Now we can build the project, but where we are calling this create group form, we need to provide the view model. So let's go there. And here we can use the function that is HILT view model to pass our view model, and it will automatically inject the view model. So I think now everything is fine and we can test the application. So let's run it. Now here you can see we are getting some errors, and it is the dependency injection error, and it is not able to get the context. So we are using context for our app preferences. So to fix it, what I will do is I will define one more module. So I will copy this and I will define app module like this. And here I will define one more function, that is provide app preferences. And I will provide app preferences. And for context, we can use an annotation that is application context. So we have context, and we can use this context here, and that's it. Now let's try running the application. Now here you can see our application is running. So let's click on create group now, and it crashed. So let's check the log to understand what is happening. Okay, so it is another HILT issue. The problem is I am using HILT, and that is why I need to annotate the activity as Android entry point. So to all my activities and fragments, I need to use this annotation because I am injecting dependencies using HILT. So let's try it again. Click on create group, and this time it is working. So let's put my name. I will change this text color later. Now before clicking on this create group, first I will open logcat. Here I can see whether the group is created or not. So now I will click the create group button. And here you can see we got some response from stream, and it says that the group is created. So it is working absolutely fine. Now what we need to do is we need to start a new activity when the group is created, and that is actually our game activity. So let's create one more activity, and inside my UI package, I will make one more package and I will name it game. Inside game, I will define an activity. So let's create an activity, and it is again an empty activity. I will name it game activity. I do not need a layout file because I am going to use Jetpack Compose. So I unchecked it and everything else seems fine. So let's finish. And this is my game activity. Inside this game activity, I will define a companion object. And inside this companion object, I will define a function that will start this game activity. So here I will write fun start game activity, or I can name it simply start. To this start function, I will pass the channel ID that we just created. So it is of type string. Now inside this function start, we will create an intent to start this activity. And to create an intent, we also need context. So here we will pass context as well, like this. Import the context. And now I will use this context to create an intent. So we have intent. The first parameter is context. The next parameter is the game activity itself. So we have class.java. Then I will write also. And here I will put some extra data. So I will also define private const val CID. Or let's write it extra CID equals to extra CID. This is the key. So we will put extra using extra CID, and for the actual value I will write CID, that is channel ID. And finally we will write context.start activity, and we will pass it, and that's it. Now we can simply call this function start. We can pass the context and CID to start this game activity. Right now we are not setting anything to this game activity, and just for testing I will write set content and then text. For the value I will pass not text field, we just need text, and for the value we will pass this is game activity, just for testing. Now whenever the group is created, we need to start our game activity. But one thing we just missed. We will not start game activity when the group is created, but we will show the bottom sheet that we created so that the creator can share the unique ID that others can use to join this group. So this is very important for this game. So we will use this game activity, but before we need to show the bottom sheet. So let's go back to main and here open the create group. So now what I will do is I will remove this hilt view model from here, and I will pass view model to this create group function. So we have view model of type MainViewModel, and we can pass the view model from here like this, and where I am displaying this create group, here I can write hilt view model like this. Now let's open create group, and here I will observe the game connection state. And to do this, I will write here val game status equals to game connection state, and we will get it from view model. So we have view model dot game connection state dot collect as state. So I am observing the game connection state. Now I passed false for this expand value. Now instead of this false, I will write here game status is game connection state dot success. So if the connection state is success, we will expand the bottom sheet. And here we are getting some error, and it is incompatible types. Here we have game connection state dot success and state of type game connection state. And it is because here instead of equals to, I need to use the by delegate, and the error is gone. We need to import the get value as well, and that's it. Now the error is gone, and whenever the group is created, we will see the bottom sheet. So let's test this thing. So this is our application. Now let's click on create group. Again, I will put my name, and you can see we have the bottom sheet that says check out the ticket, and this is our group code, and yeah, that's it. Other people can use this group code to join the game. And when we will click on this continue to game, then we will start the game activity. But right now, for this code, we are displaying a hard-coded text. And first, we will change this text to the actual group ID. So let's do it. In place of this, we need to display the actual group ID. So for this function, we will pass group ID that is of type string, and here we will just put group ID. Now for preview, we can pass anything, but here we need to pass the actual group ID, and we will get the group ID from the view model. So let's go inside main view model, and here I will define one more val that is channel, and it is again of type state flow, and I will make it as channel, and the channel can be nullable. Now I will get the channel from the game connection state, so I will write equals to game connection state dot filter is instance, and the instance that I'm looking for is game connection state dot success. Now from here I will call map not null, and here I will get the channel. And we have some compilation error, that is type mismatch, and it is because it should not be state flow but it is a flow only. So flow from coroutines, and instead of the name channel I will rename it to connected channel. That's it. Now I can observe this channel to get the group ID. So let's go back to create group, and here we can collect connected channel as well. So we have channel by view model dot connected channel dot collect as state, and for the initial value we will pass null. Now here from this channel we can get the channel ID, and we can convert that channel ID to group ID. So here we can write channel dot, we have the CID, and with the help of CID we can get the group ID. So for now I will write here group ID, and what I will do is I will define one more file inside utils, and I will name it channel extensions. So here I am going to define an extension for channel, and it will give group ID from CID. So I need the text after the colon. So that's what I am doing here. So from this group ID I will get the group ID here. I just need to import the group ID, and now we need to make the parameter nullable like this, and for text we can pass either group ID or an empty text like this. Now let's run the application again to see whether it is working or not. This time we should see the actual group ID, and you can see we have the actual group ID this time. It is working absolutely fine. Now we need to open game activity when we will click on this continue to game button. So we will go to the primary button, and here we can simply call game activity dot start. We need to pass the context and the CID. So first let's define the context. I will define context here. So we have local context dot current. We have the context, we can pass it here, and for the CID we have group ID here. So we will pass group ID like this, and it should not be null. So what I will do is I will wrap this with let. So if the group ID is not null, we will start the game activity, and that's it. Now let's run the application again to make sure the game activity is getting started, and we have the group code. Let's click on continue to game, and this is the game activity. So it is working absolutely fine. One thing that I will do is when I press back, I go to the previous screen. That I don't want. So what I will do is I will go to game activity. So we have game activity here, and I will set some flags to my intent. So we have set the flag, that is intent flag activity new task and flag activity clear task. Now this way, when we will click on the continue to game and when we will press the back button, we will exit the application, and we won't come back to this screen again. So now we have completed the create group part, and after create group we will build the join group part. Now for our main activity, just one logic is remaining, that is join group. So again I will go to my MainViewModel, and here I will define one more function. This function that we created to create a game group, the same way we will create one more function to join an existing group. So at the bottom I will define one more function, that is, let's say, join game group, and this function will join an existing game group. To this function we need to pass display name again. So we have display name of type string, and the important thing that we want to join a game group is the group code. So we need a channel ID to join an existing channel, and that is why the user will provide the group ID that we can use to generate the channel ID, and then we can join that channel. So here I will pass group ID of type string. Now we need these two parameters to join a game group. Now again, first we will connect the user. So again I will write here viewModel scope dot launch like this, and then first I will define a val connection that is equals to connect user, and we will pass the display name that we already have here. Now again we will check if the connection is a success. So we'll write connection dot is success. That means we can join the channel. So here we need the channel ID to join an existing channel, and to join an existing channel we can use the chat client. So here we can write chat client dot channel, and to this function channel we need to pass a CID, that is the channel ID that we want to join. But here we have the group ID that is randomly generated, and we need to convert this group ID to channel ID. So what I will do is, to my channel extensions I will define one more inline val. So we have inline val string dot channel ID, and whenever we will get this, we will get $channel messaging colon and the ID or the group ID. So I can use this property to convert a group ID to channel ID, and in stream the channel ID is like this: the type of channel colon and then the unique ID of the channel that we generated. So the same thing we are doing here, we are converting the given string to channel ID. So now here we can pass group ID to channel ID like this. Now we can save the result here. So we have channel equals to chat client channel and then the channel ID. Now we got the channel, and what we need to do here is we need to add a new member to this channel. So to add a new member to the channel, we will use this channel instance. So here we will write channel dot add members, and here we need to pass the user ID that we already have here. So I will write here user ID like this, and then I'll call the await function to complete the execution, and I can save the result here. So we have result equals to channel dot add members and await. Now I can check if result is success. That means the user has joined the group successfully, and in this case we can move to game activity, or we can open the bottom sheet that we created, else we can show some error. Now to emit the results, again we can use this game connection state. So here when the connection is successful, we will emit game connection state dot loading like this, and when the result is successful, that means the user has joined the channel, we will emit success like this. And the same thing we can do for failure, and for success we need to pass the channel, and to pass the channel we can use this result. So we will write result dot data here, and it will give us channel, And don't get confused with this channel. This is not a channel, but it is a channel client. As you can see, the type is channel client. So we emitted the success, and the same way we can emit the failure. So we have game connection state dot emit and game connection state dot failure. And to failure we can pass result dot error. And that's it. We have the function join game group ready that we can use. So let's call this function to our join group interface. So when the secondary button is clicked, what we will do, we will call the function join group. We already have display name and group code from the input. So we just need the view model here. So we will pass view model of type MainViewModel, and with the help of view model we can simply call view model dot join game group, and we can pass display name and group ID or group code. So we have the values here, and now this screen will also work. And to test it, first we need to create a group and then we can join the group. And to do this, we need to run 2 emulators. So let's test it. And for now, I will remove the preview because here we need to pass the view model, or we can simply write here HELT view model to pass the view model. And where we are calling the join group function, here also we need to pass the view model. So let's go to main screen, and here also we can write HELT view model like this, and it will inject the view model. So this time I will run 2 emulators to test whether our join group is working or not. Now we have 2 emulators. This is the first one and this is the second one. So let's create a group first. So I will create a group, and the display name should be, let's say again, my name. And I will create the group. We have the bottom sheet. Now this time here I will click join group, and I will put another name, let's say Nash, and the group code is BMYXOV. So we will write BMYXOV like this. Let's click on join group. Seems like nothing is happening when I'm clicking join group. And the problem is I am not displaying the bottom sheet here to this join group composable. So I think we do not actually need to display a bottom sheet here, because here user is not creating a group but joining a group, and he already knows the group code. So we will directly open the game activity. So let's do it. Come to join group, and here we will again observe the game connection state. So here I will write val game connection by view model dot game connection state dot collect as state like this. Now here we will check if game connection is game connection state dot success. In this case we will just open the game activity. So we will write game activity dot start. We need to pass the context. So let's get the context as well. We have local context dot current. We will pass the context and the channel ID. So we will get the channel ID from game connection dot channel dot CID. So we need to cast it to success as well. So everything else is fine. And now let's run the application again. Now this time let's join group, and again I will put some name and then the group code. So the code is BMYXOV. So we have BMYXOV. Let's click on join. So it seems like we have some error in our code, and again nothing is happening. So what we can do in this situation? So we need to debug. So what I will do is I will go to my main view model where we have written the logic to join game group. So open this function, and I think our code is coming inside this else part. That means some error is happening. So I will put a breakpoint here like this, and then I will attach the debugger to my emulator. So let's attach the debugger, and now I will click on join group. So you can see we are getting an error, and here we can check what is the error. So we have this error, that is a 404, and it says can't find channel with ID messaging this. So I think we are having a problem while creating the channel ID. And here I have written this, that is a string, but I wanted to refer to this. So I had to put a dollar here like this. Now it should work. So let's try again. So I will rerun the application. Let's click on join group now, and this time it should work. So we clicked here, join group, and you can see we have our game activity. So it is working absolutely fine. And if I go back, the app exits. So it is working fine. So now we have completed our main activity. We created the create group logic and we created the join group logic. Now we need to work on the game activity, and there we will create a canvas where the host can draw and other people can guess. But we also need to give the host a word to draw, and to get that random word we will use an API. So first, inside our data package, I will define a new interface. So I can name it RandomWords API like this, and it is an interface, and I am going to use retrofit for the network call, and I already have a URL ready that will give me a list of English words, and you can use the same URL. So this is the API that we will use for fetching the list of English words, and you can see we are getting a list of strings in the response. So we are going to use this API for the list of words. So let's go back to our project now. So here in my interface, first I will define a companion object, and inside the companion object I will define an operator fun invoke. So we have operator fun invoke like this, and it will return us this RandomWords API. But first I will define the base URL here. So we have private const val base URL, and it is this URL, and I need to remove the scribble underscore words.json. So I will cut it. Now here I will define a get request. So we have get, and this is the URL that we want to get, and here I will define a suspending function. So we have suspend fun get random words, and it will return a list of string like this. Now here to my operator fun invoke, I will define the return type as RandomWords API, and here I will write return retrofit.builder. We will add the base URL, that is this base URL, and then we will add the converter factory, and we are going to use Moshi converter factory. So we will write here Moshi converter factory.create, and then finally we will build the retrofit, and from the retrofit we will create our API. So we have RandomWords API class.java like this. Now we can use this API to get the list of random words. Now to consume this API, I will define one more view model for my game activity. So inside our project, I will close the emulator for now, and inside our project's game package, here I will define one more Kotlin file class, and it is GameViewModel. Now it is a view model, and that is why I need to extend or inherit view model, and because it is a held view model, I need to use held view model like this. And again I will use inject annotation. So we have inject constructor, and we can import inject like this, and to the constructor I will pass my RandomWords API. So we have private val RandomWords API of type RandomWords API. Now we need to define in module how to get this RandomWords API. So I will go to the app module, and here again I will write provides and then fun provide RandomWords API, and it will give us RandomWords API dot invoke like this. And we can define the return type here. It is not necessary, by the way. So we have the RandomWords API provider, and I will also mark it as singleton like this. Now inside my MainViewModel, I can write an init block. Now inside my MainViewModel, I can consume the RandomWords API because I already have the instance now. The app module will provide the RandomWords API instance. But I think we can create one more layer, and we should not directly call the API from the view model. So inside my data, I want to create a new class that is, let's say, RandomWords. And again, it is a constructor injection. And to this class, we will pass the API that is private val RandomWords API of type RandomWords API. And this class will give us the random words. So here we will define suspend fun get random words, and it will again return a list of string, and here we will call val words equals to RandomWords API dot get random words. Now from this list of words we will fetch 3 random words, and to do this we can use return words dot as sequence, and then we can shuffle the list, and from this shuffled list we can take 3 items as list like this. Now this function will give us 3 random words, and instead of using the RandomWords API directly, this time we will use random words in our MainViewModel. So here we will write random words like this, optimize the imports, and whenever the MainViewModel is initialized, we will fetch the random words. But before fetching the random words, first we need to connect to the given channel, and that is why I will define 2 functions here. The first one is a private fun fetch channel information, and it will get the channel information of the current game. And then we will define one more function that is private fun get random words, and here I can use a view model scope because I am going to call a suspending function. So I will write here val random words equals to random words dot get random words. Now to test this whether our API is working or not, we can just print random words. And just for now, to test this get random words, I will remove this private from here, and I will call the function directly from our game activity. So because I want to inject the view model that we created to this activity, I need to annotate it as Android entry point. And then I can inject the MainViewModel here. And to inject the MainViewModel, I can write private val viewModel by viewModels, and it will give us MainViewModel, and here I can call viewModel dot get random words. And for testing, I can put a breakpoint here to the println, and I can run the application in debug mode. And here you can see we are getting the random words. So it is working absolutely fine. Now after getting the random words, actually we need to do this before the random word thing. So first, whenever our MainViewModel is initialized, we need to fetch the channel information. So here I will call fetch channel information, and now we need to write the implementation of this function, that is fetch channel information. To fetch the channel information, we need a couple of more things. So I will define some more parameters in this MainViewModel's constructor. So to fetch the channel information, we also need the chat client. So I will define a chat client here. And the most important thing that we need is the channel ID to fetch the channel's information. So we also need to pass CID here, that is a string. But now the problem is RandomViewModel cannot inject all these parameters here, because we can get the random words, we can also get the chat client, but how to get this channel ID? It is only available after creating a group or joining a group. So we need to pass this parameter dynamically. And that is why instead of RandomViewModel, I am going to use assisted injection here. So I will remove this RandomViewModel, and in place of inject, this time we will use assisted inject, that is from Dagger. So I will optimize the imports, and the assisted parameter here is the CID. So I will annotate this parameter as @assisted. Now inside my MainViewModel, I will create an interface. So I will define an interface, and it is assisted factory. You can name it anything, but it is actually our assisted factory. And I will annotate it with assisted factory. And to make this annotation just assisted factory, we need to change this interface name because both are same now. So what I will do is I will change it to game assisted factory, and now here I can write assisted factory only, like this. Now inside this assisted factory, I will define a function. So we have fun create. Now the parameter, the assisted parameter that I want is this channel ID. So here I will pass CID, that is of type string. Now I will create a companion object, and here I will define a function, and we can name it fun provide assisted, or we can name it provide game assisted factory. And this function will return us a view model factory. So here we can define view model provider dot new instance factory as the return type. And now we can return the new instance factory from view model provider. So here we will write return object and then view model provider dot new instance factory, like this. Now this function provide game assisted factory will give us the new instance factory. And here inside this object that we created for new instance factory, we will override a function, and that is override fun create. And this function will actually create our view model. And to create the view model, we will use our interface that we just created. And here we need to write the return type as well, because this create function will create the game view model like this. And now we need to pass an instance of this game assisted factory here to the function provide game assisted factory. So here I will write factory, or we can write it as assisted factory of type game assisted factory, like this. And here in place of this return, we will write return assisted factory dot create, and we will pass the CID. So here we will also define CID, another parameter. So now we have assisted factory and CID. So we can pass the CID here to this create function, and we can cast it as T, like this. And that's it. Now we can use this provide game assisted factory to inject CID in our game view model as an assisted injection. So let's do it, and we will inject the game view model inside our game activity. So we already have this Android entry point here, but this time instead of creating the view model like this, we will do it like this. And here inside the trailing lambda, we will provide the factory. And to get the factory, we need GameViewModel dot provide game assisted factory. And to this function, we need to provide two parameters. The first one is the assisted factory instance, and the next one is the CID, that is our assisted parameter. So what I will do here is I will write @set and then inject. So what I will do is I will inject the game assisted factory here. So we have late init var game assisted factory of type GameViewModel dot game assisted factory, and we can pass it here game assisted factory. And for the CID, we can get it from the intent, because whenever we are starting the game activity, we are getting the CID in the intent. So what I will do is I will write here intent dot get string extra and then key CID. So it is extra CID, not key CID. So here I'll write extra CID. And I will use this operator because I am sure that whenever we are starting the game activity, we have the CID. So I can use this operator. So now we have our view model with an assisted injection. Now let's go back to game view model. And now we can write the implementation for this function, that is fetch channel information. And because I am going to use some suspending functions, I will use a view model scope here. So we have view model scope.launch, and now I will get the channel from the chat client. So here I will write val channel equals to chat client dot channel, and here I will pass the CID. Now it is a channel client and not a channel, so I will rename it to channel client. Now from the channel client, we can watch the channel, and to watch the channel, we can write channel client dot watch dot await, and we can save the result in a val. So we have val result equals to channel client dot watch dot await. Now if we have a success on the result, we can get the channel information. So here I will write result dot on success like this, and here I will get the channel, and from this channel I can get all the information that I want. And as I told you that I will call the getRandomWords function after getting the channel, but this getRandomWords will be called only for the host of the game. And first we will identify whether the current user is the host or not. And if the current user is a host, then we will call this getRandomWords function. So first, let's get the host information. And to store it, I will create a state flow. So we will define private val is host equals to mutable state flow. And I will put the initial value as false. That means the current user is not the host. Now to observe it outside this game view model, I will define a val is host, and it is of type state flow and boolean, and for the getter I will write is host, so that we can use this immutable property outside this class. Now here I will put the information of is host. So I will write is host dot value equals to, we will get the channel information from it. So we will write it dot extra data, and we will use key host name, and if it is equals to current user's display name, that means the current user is the host. So here we will write chat client dot get current user dot name. So if the current user's name is equals to host name, that means this user is the host. And to minimize this thing, we can define an extension function for the channel. So I will copy this part and I will go to the channel extensions that we created. And here again, I will define one more extension, host name. And here to the getter, I will write this dot extra data key host name, and it is nullable, and we will convert it to string like this. Now we can use host name instead of writing this at MainViewModel. So here we can write it dot host name equals to chat client dot get current user dot name. Now after this we can write if is host dot value is true, then we can call get random words. Else we can do other operation that we want for a normal participant. So for now our fetch channel information is ready, but I think we can put this line at the top because we may need the channel client in other places as well. So I will put it here like this, and I will make it private. So we have private val channel client, and the channel client is initialized using CID, and here we are getting the channel information. Now we will subscribe to a channel event. So I will define one more function, that is private fun subscribe to channel events, and inside this function I will subscribe to a channel event. So the first event that I want is chat client dot subscribe for, and we will define the type that we want here, and the type that I want for now is channel updated by user event. So I want to subscribe for this event. Let's import this function as well. So now here we have an event, and I will get the callback whenever the channel is updated. So basically when a new word is selected for the game, we will update the channel, and here we will get the selected word. So to track the selected word, I will define one more mutable state flow here, and I will do it the same way as we did here. So again I have a private val selected word that is of type mutable state flow, and I have selected word to observe it outside the MainViewModel. So inside this trailing lambda, first I will get the channel from it dot channel, and now from the channel I will get the selected word. And the same way I defined this extension function to get the host name from channel. I will define one more extension property, not a function, to get the selected word. So here I will write selected word, and this time I will get key selected word from the extra data of the channel. Now let's go back to MainViewModel, and here I will write selected word dot value equals to channel dot selected word like this. Now we have the selected word. Now what I will do is I will subscribe to channel events as well. So now we have fetch channel information, we have subscribed to channel events, and we also got the random words that we want to display to the user. Now we need to display a pop-up whenever the game activity is opened, and it is opened by a game host. So there are two cases. If a normal participant go to the game activity, he will not see the random words pop-up. He need to guess the word. And if a host goes to the game activity, he will get 3 random words, and from those words he needs to select one that he will draw. Now let's first create the flow for the host, and the host will see a pop-up containing 3 random words. So first I will define a dialog for the host for displaying these random words. So inside my game package, I will define a new Kotlin file class, and I will name it word selection dialog, or you can name it whatever you want. Now here first I will define or design a card that will display 3 random words to the user or host. Now here you can see I have a very simple design for the word selection, and it is a simple composable function where I have a card, And I have passed this word selected parameter to get the callback whenever a word is selected, that I am passing here. So the design is very simple. And now we will define a dialog where we will display this word selection dialog view. So I will define one more composable function, and it is my actual dialog. So I have fun word selection dialog like this. And inside this function, I will use another function that is dialog like this. And I don't want this dialog to be dismissible. So I will not do anything on the dismiss request, and inside the trailing lambda, I will call the word selection dialog view like this. And these two parameters I will pass to this function as well. And now I can pass words and word selected. So we have words and word selected. Now we can use this word selection dialog to display a dialog. Now for the game screen, I will define one more file. So this is my game screen, and it is another composable function. So let's say it is game screen like this. And inside this function, I will pass the view model, that is my game view model. And I will check is host by view model dot is host dot collect as state. Now we need to do this import, that is get value. And now I will check if is host, then in this case I will show the word selection dialog. And the words I need to get from the API call that I am already making. So what I need to do is I need to get the random words from this API call or from this get random words instance. So I will save the random words in another variable that I can use outside this class. So we can copy this, and this time it is underscore random words, and it is a mutable state flow of list of type string. And here I will write random words, and it is a state flow of list of type string. And here I will return random words like this. Now we have two vals with a similar name. So here I will change it to random word like this, and it is our actual random words here. Now let's go to this function, and here we have a random word for getting the random words. Now once we have the random words, we will emit it to our state flow. So we have random words dot emit, and we will pass the random words that we have here. Now go back to game screen, and here we can collect the random words as state. So we have val random words by view model dot random words dot collect as state. We have some compilation error in our game view model. So let's go here, and we need to define an initial value for the random words. So I will make it nullable, and I will make the initial value as null, and I will make this nullable as well. Now here inside game screen, we can check if it is a host and random words is not null. So in this case, I can pass random words, and I can use this operator here because I have already checked that it is not null. And for word selected, we can pass a trailing lambda like this. So I can do it like this. I will remove the names, and I will put the lambda as a trailing lambda. So now we have the word selection dialog, and whenever a word is selected, we will get it here. So we have selected word here. Now whenever the word is selected, we will call a function from the view model, and we will update the selected word. So we need to create a new function, view model dot set selected word, and we need to pass the selected word like this. So let's go to view model and define a new function. So here I will define a new function, set selected word. It will take the word that is given and now it will update the channel. Because we are going to update the channel, we will use a view model scope here like this. Now we will update the channel inside this function. And to update the channel, we can use this channel client that we already have here. So what we will do is we will write channel client dot update, and to this update function we will pass the extra data. And here we want to update the selected word. So what we can do is we can pass a mutable map of, and here we can pass key selected word to word. Now the problem here is when we will update the selected word, it will remove all the existing information from the extra data of the channel. And when we are creating the channel, let's go to MainViewModel. And here when we are creating a channel, we are setting all these informations as well. So what we can do is we can set the key name and key host name as well, so that we do not lose the data. Now to get the name and the host name, we can use the chat client. So here I will write val host name equals to chat client dot get current user and then name. And if it is null, we will stop the further execution. So here I can write return at launch. Now we have the host name. So I will set the host name from here. And for the group name, here you can see I am using display names group. So to make sure it is consistent everywhere, what I will do is I will define one more extension function. So here I will define one more, and this time it is group name. So I will write here at this and then apostrophe s and then group like this. So now here I can use host name dot group name, and here also to my main view model, instead of writing a string, I can write display name dot group name like this. So let's go back to game view model, and here after the update function we need to call await, and it will update the channel with the selected word. Now let's go back to game screen, and here we are calling the set selected word. And now we can test whether we are getting the word selection pop up or not. So first we need to set this game screen to my game activity. So now instead of this text at the set content, I will call game screen, and we need to pass the view model, and we already have the view model here, so we can pass it like this, and we have the game screen ready. Now let's test to make sure it is working fine. Now let's create group. Again I will put my name. We have the bottom sheet, and the application crashed, and the problem is the CID is not in the correct format here. I already told you that the CID should be in this format, that is the type of the channel, then colon, and then the unique ID. And in this case I am just passing the unique ID. So let's fix it first. And to fix it first, let's see what we are passing for CID. And here you can see we are passing the group ID. So instead of group ID, I will pass the channel here. So let's say we have channel and then channel, and it should be from Stream SDK. So this channel we need. Now in place of this group ID, we can set the group ID from channel. So we will write here channel dot group ID, because we have already defined this extension to get the group ID from channel. And to make sure it is not null, I can use an else operator. So we have the group ID here, and now in place of using this group ID, we will use channel, and if it is not null, we will use it.cid like this. And now our application should work. Just we need to pass channel in place of this string. So for now I will pass null here, and one more place we need to change, and here instead of passing the group ID, I will pass just channel. Now let's run the application again to make sure it is working fine now. So create group, I will put my name again, create group, and then continue to game. And you can see we are getting the word selection dialog. So it is working absolutely fine so far. Now after this, we will design the game screen. And in game screen, we have two options, actually three options. So I will write it here. The first one, when the host joins the game activity. So we have host, then we have a normal participant. In both cases, we need to display a chat window, but host cannot send the message to this chat window. Normal participant cannot draw and should not see the word selection dialog, and host should see the word selection dialog, and host should be able to draw in the screen. So we need to cover these situations. Now first, I will define a bottom sheet scaffold, because for the chat window, I will make it inside a bottom sheet, because user can move it up and then enter the chat message, because in mobile we have limited space for the user experience. So I am going to use bottom sheet for the chat area, and in the remaining area I will provide the drawing space, because a user needs a big space to draw something. And to create bottom sheet, we can use the code that we already created. So we have here group bottom sheet. So I can just copy this function and I will paste it inside my game package. So I will create a new Kotlin class file here, and I will name it, let's say, game screen bottom sheet. You can name it whatever you want. And here I will paste the function that I just copied. Now we don't need this part because user is going to expand the sheet. So I will delete this part. I don't need this flag, and I will change the function name to game screen bottom sheet like this. Now to this function, we will pass the bottom sheet scaffold state, the sheet content, and the main content. We will design the sheet content later because it will contain the chat things. But first, let's focus on the main content. Now let's go to game activity. And here we are setting the content as game screen. And now we will go to game screen. And here I will remove these things and I will define one more composable function. And we can name it something like game drawing. For now, let's keep it game drawing. And we also need the view model. So we have game view model. Now inside game screen, we will define a bottom sheet scaffold. So we have bottom sheet scaffold. It is an experimental API. So we need to annotate it with opt-in experimental API annotation to remove this compilation error. So I will add this annotation. For the sheet content, we will pass it later because right now we do not have the sheet design. Now for the main content, we will write game drawing and we can pass the view model, and we will design the bottom sheet later. Now inside game drawing, there are two cases. The first one, when this is host is true, and else when a normal participant is playing the game. So for now, I will define two more functions. So we have composable fun game drawing host, and one more that is composable fun game drawing normal. So we have two more functions. Now here, instead of checking this random words, But what I will do is I will cut all these things to game drawing host, and we need the view model, of course. Now we do not need this thing. This thing we will check here, and we will write if is host is true, then game drawing host, else game drawing normal, like this. In both cases we need to pass the view model, so we will pass the view model like this. Let's add this parameter to the game drawing normal composable, and here we do not need to check is host because it is already the host. Here we will just check if random words not equals to null, we will show the word selection dialog, and that's it. And here one more logic we need to add, because if the random word is already selected by the user, then in that case we will not show this dialog. So we will go to view model, and let's open the game view model, and here we have this selected word that we can observe. So we are setting the selected word here. You can see we are setting the selected word. So whenever a word is saved to the channel's extra data, we will get it from this state flow. So in my group bottom sheet, not here, in my game screen actually, here I will write val selected word by view model dot selected word, and then again collect as state. Now we will check if the selected word is not null. So if random word is not null and selected word is null, so in this case we will show the word selection dialog. I can write word here because it is a small naming conflict. So we have word. Now once we have the selected word, we will not show the word selection dialog, but we will show the drawing area for the host. And for creating a drawing area, I am going to use Sketchbook that my friend Jay Wong has created. So we already added this library in our project when we created the projects. So we just need to use it now. So I will define one more composable now. So a lot of composable functions, and I will name it Sketchbook. So for host, we will provide the Sketchbook. So here we can write Sketchbook like this. We can just call the Sketchbook. And now inside the Sketchbook, we will define the drawing area. So I will extract this composable to a separate file. So I can just cut this function, and I will define one more here, that is Sketchbook. So we have Sketchbook like this, and we can create the function composable Sketchbook. Now inside this function Sketchbook, I will define a canvas where user can draw. So for creating the Sketchbook, we can use an existing function that is in the library Sketchbook, and the function name is Sketchbook. So what I will do first is I will change this function name to, let's say, Sketchbook screen, because Sketchbook name is conflicting with existing name. So I will also rename this file. So we have refactor rename and then Sketchbook screen like this. Now inside this function, I will create a Sketchbook. You can see we have this function Sketchbook, and before creating the Sketchbook, I will create a box. So we have a box. I will pass a modifier to this box, that is modifier dot fill max size, and then inside this box I will put the Sketchbook. Now I also want to add a border to my box, so I will write border, which should be, let's say, 2dp, and the color should be color dot black. So I am just putting a black border, and then for Sketchbook we will pass the modifier, again it is fill max size, and I will set some padding here. So we have padding, let's say 12 dp. Now for Sketchbook, we also need the Sketchbook controller. So I will pass this parameter to this Sketchbook screen function. So here I will define controller of type Sketchbook controller, and for the controller we can pass this like this. I need two more parameters for my Sketchbook. The first one is background color, and I will set the color as white, and then I also need on path listener. And from here we will get the callback whenever user draws something on the sketchbook, and then we can broadcast this drawing to all the other participants so that others can see the drawing and enter the guesses in the chat window. So we will do it later. For now our sketchbook screen is okay, and we can use this sketchbook screen for our host. So let's go back to game screen, and here we will call sketchbook screen. We also need to pass a sketchbook controller. So what we can do here is we can create a sketchbook controller. Let's say we have sketchbook controller equals to remember sketchbook controller. Now we have the sketchbook controller, and we need to set the stroke width and the stroke color for the sketchbook controller. So we will set stroke width, and we can set it to, let's say, 8 dp, and we also need to set that is paint color, and for color we can use black. And this function stroke width takes a float and not dp, so I can pass here, let's say 10f, that is a float value. And now I can pass this sketchbook controller to my sketchbook screen, and it seems fine now. Now let's check again. Inside our game activity we have the game screen. Open this game screen. Now inside game screen we have a bottom sheet scaffold. We don't have the sheet content for now, but we have the main content, that is the game drawing. Inside game drawing we are checking if it is a host, then in that case we are calling game drawing host, else game drawing normal. We will design game drawing normal later, but right now inside game drawing host we are showing the word selection dialog if the word is not already selected. In case of else we are showing the sketchbook, so it should work. So now let's run the application and see whether it is working or not. And this pop-up is coming. Let's select book, and the dialog is gone. Now if I draw here, you can see I can draw it, so it is working absolutely fine. And if I slide it up, it's not happening because we do not have any content for the bottom sheet that we need to design, but for now it is working fine. So let's go back to the project, and we need to design this game drawing normal. For this game drawing normal we will define a box. It is the same thing. Again we will use the modifier as fill max size, and inside the box we will define an image. So we have image. We need to display a bitmap here, and for content description we can pass an empty string, and we need to provide the actual bitmap that we want to show. So for now I am commenting this line because I don't want any compilation error. So now the problem is the host can draw, but how the guest or a normal user will receive the drawing? So there can be a lot of options to do this thing. Because I want to make this tutorial very quick, I am going to use Firebase Realtime Database for this. So what I will do is I will convert the drawing to a string, and then I will receive the string and I will display it to the other users. So first I need few functions. The first one is to convert the bitmap to a string, and then from string I need a converter that will convert it to bitmap again. And for this task I will define one more extension file inside the utils package. So we have bitmap extensions, and inside this file I will define these two functions. The first one will convert a given bitmap to base 64 string, and the next one will convert a given string to bitmap, so that we can send a bitmap using string, and we can convert a string to a bitmap again when we need to display it to the other users. And the next task is to integrate Firebase Real-Time Database in your project. So I am not going to cover this part here. You can do it. It is very easy. So what I will do is I will add Firebase to this project, and I will set the Firebase database in test mode because I do not want to add all the authentications of Firebase. For now, we will use the Firebase real-time database in test mode so that we can simply write and receive information from Firebase database. Now let's go back to MainViewModel. So we have our MainViewModel, and here we will define one more function. So let's define fun. It is fun, and then broadcast bitmap. Now this function will take a bitmap that we want to broadcast, and then we will broadcast this bitmap to all the users, and for this we are going to use Firebase real-time database. So the first thing that we will do here is we will get the string format of this bitmap. So we will write here string bitmap equals to bitmap dot to base 64 string. Now we will set this string bitmap to Firebase real-time database. And to set the string to Firebase database, first we need to create an instance of Firebase database. So we will go to the top, and here we will define private val Firebase DB, and we will get it from Firebase database. So we will write Firebase database dot get instance dot reference, and we can write here get reference because we also need to pass the path, and for the path we will use the group ID. So here we will write channel client dot group ID, and to get the group ID from channel client we need to create an extension function or extension property. So here we have group ID that is from channel, but we also want it from channel client. So we will write here channel client dot group ID. Now we can use this group ID to get the group ID from the channel client that we are doing here, and we have the Firebase database reference ready, and with the help of this instance we can save the string to Firebase database. And to do it we will simply write here Firebase database dot set value, and then we will pass the string bitmap like this, and now it will save the string format of the bitmap to Firebase real-time database. Now let's go to sketchbook screen, and here you can see we have an on path listener here, and from here we can get the bitmap. And to get the bitmap from here we will create a bitmap, and we will get sketchbook controller, that is controller, and from controller we will get the bitmap, and we will convert it to Android bitmap. Now we can send this bitmap to our function that we will define here. So here I will write, let's say I will define a bitmap listener, and it will take bitmap as a parameter, and it will return unit like this. Now here I can call the bitmap listener, and I can pass the bitmap that I got. Now where I am calling the sketchbook screen, I also need to pass a trailing lambda, and here I will get the bitmap. And here I have the view model. So what I will do is I will call view model dot broadcast bitmap, and I will call it. Now it will save the bitmap to Firebase real-time database. Now again go to MainViewModel, and here when it is not the host, so when we are fetching the channel information, when it is not host, what we will do is we will register a listener to listen for Firebase real-time database changes, and from there we can get the updates of the drawing. So here I will write a function, let's say subscribe to Firebase DB. Let's create this function, that is private fun subscribe to Firebase DB, and here I will use Firebase DB dot add value event listener, and to this we will pass object value event listener like this. We need to override some functions. So we have on data changed and on data cancelled. Now inside on data changed, we will get the value. So we will define string bitmap here, that is snapshot dot value, and for the type we will pass string class.java. Now we have the string bitmap here, and we can convert the string bitmap and we can broadcast it using state flow. So let's define a state for this string bitmap. So at the top, I will define one more property, that is new drawing image, and it is a nullable string. And when I am reading the value, so here I will write new drawing image dot value equals to string bitmap, like this. And one more thing we can do here is we can check if snapshot dot exist, that means a data is there, or else our application can crash. So in this case, we will get the string and we will broadcast the string using state. Now inside our game drawing normal function, we will get the new drawing image value. So I will define here, let's say drawing image equals to ViewModel dot new drawing image, and then dot value, like this. And now we can convert this image to a bitmap. So we will write here drawing image, or we can simply write here if drawing image is not null, then we will do this thing. Or I can put it inside the box. So if drawing image is not null, then I will define an image. So we can write here drawing image dot to bitmap, and then as image bitmap to convert it to a image bitmap. And to solve this nullability issue, what I can do is I can write it like this. So we have drawing image dot to bitmap dot as image bitmap, and if it is not null, we can display it. So for bitmap, I will write it and that's it. Now as a normal user, we should be able to see the drawing. So let's run this application and see whether it is working or not. And this time we will run the application in two emulators. Let's select skating. So I will draw something here. I am trying to draw a skate. Let's draw anything. And in the next emulator, you can see the drawing. Here we are not able to draw anything, and it is working absolutely fine. Now the last task is to display a chat window here where the user can submit the guesses, and if the guess matches with the correct word, we will finish the game. Now let's come back to game screen, and here we need to design our sheet content. And I just realized that we designed this game screen bottom sheet that we are not using. I just defined a bottom sheet scaffold here again. So this is we will not do. What we'll do is we will use this one, that is game screen bottom sheet. So here we will call game screen bottom sheet. We need to pass the bottom sheet scaffold. So we can pass here val bottom sheet scaffold equals to remember bottom sheet scaffold state. We can pass the scaffold here, and then we have our main content, that is game drawing, and we can pass the view model. That's it. Now for the sheet content, I will define a new file. So I can name it, let's say chat window, or you can name it whatever you want. Now again, it is a composable function, and I will name it fun chat window, like this. And I want to see the preview, so I will define a preview function here, and it is also a composable. So we have fun preview chat window, and then chat window, like this. Now split it, close this, and we can see the design here. Now for the chat window, again we can use a constraint layout. So we have constraint layout. I will use a modifier for this constraint layout. So we have modifier and then modifier dot fill max width. I want to fill the maximum width, and for the height I will set some specific value. Let's say I want a height of 400 dp like this. Now inside this constraint layout, at the bottom I will define an input field and also a button. So for chat we need an input field and a button where user can write the input and then press the button to send the input or submit the guess. So we have to design a text field and a button, and we also need to show the submissions in a list, that is our chat window. So basically we need three components here. The first one is the text field. So let's define app text field, and for label we can write string resource r dot string dot enter guess. So I am using this label for the app text field, and after the app text field we need a button. So we have button. For this button I will pass shape as well because I want to make it as a circular button. So we have shape and it is circle shape like this, and then I will use a button icon. So here I'll write icon, and then for icon I can use a painter resource and then r dot drawable dot ic send. I have already defined all the icons, and for content description we can pass an empty string. So we have the button, we have the text field, and above these two things we need to display the chat list, but that we will do later. For now let's set the constraints for these two things. So I will define text field and send button, and I will also define for the list that we will use later. So let's define chat list and equals to, we can use create refs. So this create refs will create all these three constraint layout references. Now here I am using my own custom composable, that is app text field. So what I will do is I will wrap this app text field inside a box. So I have box like this, and inside this box I will put the app text field, and now I will set the constraints to this box. So I will pass modifier equals to modifier dot constraint as, and I will pass the constraint layout reference and a trailing lambda. Now inside this trailing lambda I will set the constraints. So I want to set start to parent dot start. I want to set bottom to parent bottom, and for the end I want to constrain it to the start of this button. So here I will write end dot link to send button dot start like this, and that's it for the constraints for this box. Now I will set some constraints to this button, but one thing I just forget, I need to set the width to dimensions dot fill to constraints like this. Now here I will use constraints for the button, and again we need to pass the modifier for this. So we will write modifier equals to modifier dot constraint, and I will pass send button. So we have send button, and then a trailing lambda. Inside this trailing lambda I will set the constraints. So first I will set the end to parent end, and then bottom to parent bottom like this, and after this I will set the width and the height. So I will set the width as, let's say, 52 dp and height also 52 dp like this. So we have the button and we have the app text field, and now let's preview our composables. So you can see here we have a nice layout. We have this app text field and we have this button, so we can use it, and here we will display the guesses, but that we will do later. But first we need to take the input and we need to send the guest to the channel. So to do this, again, we will need the view model to the chat window. But first, let's go to game screen. And for the sheet content, we will pass chat window like this. And now let's test it. So now if I pull the bottom sheet upwards, we can see we have the input field and we have this button that we can use to enter the guesses. Now, one important thing, the host cannot write a guess. Only other participants can write a guess. So what we will do is we will open this chat window, and here I will pass a flag. So I will pass is host, that is Boolean. And now to my text field, or what we can do is we can hide this layout when is host is true. So here we can write if is host, and if it is not true, then only we will display these UIs like this. Now when the participant is a normal participant and not a host, then only we will see the input field and the button. But for chat messages, everyone can see it. So we will design it. But first we will code this part where the user can enter the guess and send it to the channel. So let's go back to the game screen. Now to the chat window, we need to pass is host. And I think instead of passing is host, let's pass the view model. And we can use this line to collect the is host property from view model. So here I will write view model instead of is host. So we have game view model, and I will use this line to collect the is host property. Now everything else is fine. And whenever the send button is clicked, we need to get the input from the app text field and we need to send it to our channel. And to do it, again, we will define a function in the game view model. But first, we need to get the input. So for this, I will define a var guess, and I will use the delegate remember, and I will define a mutable state of and an empty string like this. We need to import remember, and that's it. Now we can pass the guess to the app text field. So here we can pass value equals to guess, and on value changed, guess equals to it like this. Now it will work. Now we have the input in this guess. So whenever the button is clicked, we will send the guess to the channel. So we need to call view model dot send guess to channel, and we can pass the guess here. And then finally we will make the guess to empty string again. So we need to define this function. So let's create it inside view model. So we have the function send guess to channel, we have the guess, and now we need to send this guess to the channel. And to send the guess to the channel, we can use this channel client that we already created. So here we will write channel client dot send message. We will pass a message, and for the user, we will get the user from chat client. So we have chat client dot get current user, and for the text, we will pass the guess, that is a string. Now finally we will call await, and because we are using await, we need to use a view model scope here like this. Now send guess to channel is ready, and we also need to observe the messages for this channel. So we will define one more function. For now we have the send guess to channel working, and for the chat window preview, we can pass here hilt view model like this. So let's go back to game window, and here we will call one more function whenever the game view model is initialized, and it will be to receive all the incoming messages on the channel. So let's call one more function here, that is subscribe to new message event, and again we will define this function. So I will copy this thing because we are going to do the same thing. Just this time we will use new message event like this. And here we will get the new message event. And we will change the name to subscribe to new message event. And now whenever we will get the message, we will check if the message is equals to the selected word. And if the word will match, we will finish the game, or we will send a new message that, hey, this user has the correct answer. And with this, we also need to save the new messages to a list so that we can display it to our chat list. So first, let's define a new data class. And inside data, I will define one more class, that is game chat message. And it is a data class. To this class, I will define two parameters. The first one is val user of type string, and then val message of type string. So we need user and message. Now let's go back to MainViewModel, and here I will define one more mutable state flow. So I will copy this thing and I will define an underscore game chat messages. It is a mutable state flow of type list of type game chat message. And for this public val, we will write game chat message like this. It is of type state flow of type list of type game chat message like this. And here I will return game chat messages. So from this val, I can observe all the messages that are coming to the chat. Now let's go to the bottom where we defined the function. And here first we will check if it dot message dot text dot to lowercase. I will change the text to lowercase. If it is equals to, and this to lowercase function is deprecated, so instead of this I can use, I think, lowercase like this. If it is equals to selected word dot value dot to lowercase and again lowercase, we can put a null safety here like this. So if this condition is true, that means the user who sent this message is the winner. So we can finish the game here. So we can write finish game or anything. So we have one more function, private fun finish game, and we can send the user. So we have it.user and we can add it to the finish game function so that we can know who is the winner. Now this condition will finish the game, but we also need to get all the messages that are coming. And for this, I will use underscore game chat messages dot value equals to, I will use the game chat messages dot value, and I will add a new item to the list using this plus operator. So I will use game chat message like this, and for the user I will pass it dot user dot name, and for the message I will pass it dot message dot text like this. And now with the help of this game chat messages, I can observe the incoming messages. So let's go back to, we have some compilation errors, I think. So let's check what is the problem. Where is the problem? So the error is here and it says we cannot use this operator with nullable. So what I will do is I will go to the game chat messages, and instead of null, I will pass an empty list. So I can write here list of, and here also instead of null, I will use non-null list. So that's it. The error is gone now. It's working fine. Now let's go to chat window, and here we can collect the game chat messages. So let's write here val game chat list by viewModel dot game chat messages, and then again collect as state. Now I will go down, and here I will define a lazy column. So we have lazy column, and for the content I will pass items and then this game chat list, and in the trailing lambda we will get the item. we need to use this items. Yeah, this one. So we have the item, and for each item we can display a normal text that I already defined in my components. And for the text, I will define item dot user and then colon and then item dot message, like this. And for the size, we can pass, let's say 18 sp or whatever you want. You can play with the sizes. So this is fine. Now let's test this application to make sure it is working fine. Create group Belal Khan and create group XVAMH6. So we will join group here, XVAMH6. It is display name XVAMH6. For display name, let's put Jwoong, join group, and from here continue to game. So we will select a word, that is monster, and here you can see we are not getting the input field and button, but here we are getting the input field and button. If I draw something, I am getting it here. If I write something here, let's say MONS, and if I send it, so you can see we are getting the chat messages, and here also I can see the chat message. So everyone who will send the message to this game, we will see it here in this list. We can set a little bit of padding and that will make it look good, but that is okay. Functionality wise, it is working absolutely fine. Now the final thing that we need to do is we need to code the finish game function. So let's do it. Now let's go back to MainViewModel, and here we have already declared the function that is finish game. Now here we will just send a message to our channel that this user has the correct answer. So here I will write channel client dot send message, and to this function we will pass the message, and for message we will pass the text. So I am writing a simple text that congratulations, this user has the correct answer. And for the type of this message, I will pass system, like this. And finally we will call await to complete this operation, and because it is an await function that we are using, we need to use viewModel scope dot launch, and that's it. Our finish game function is ready. Now let's run the application again and test whether it is working or not. So again I will put my name Belal Khan, create group, and here I will join the group. Now let's put the code, that is VTBMVC. So I will put Jwoong's name here, and we have VTB and then MVC. So we have MVC, like this. Let's click on join group, and from here continue to game. Now let's select the text riding. Now here we have the bottom sheet, and in this side we have the input field and the button. Now let's draw riding. So I will try to draw a car here, very bad car, and let's say this is steering and this is the rider or whatever. Very bad drawing. So now here I will put some guess, let's say ride. So the guess is coming. Now I will put the correct guess, riding. And that's it. You can see, congratulations, Jwoong has the correct answer. And here also we are getting the winner message. So it is working absolutely fine. Now few features are remaining that you can complete by yourself. For example, adding number of rounds option, limiting the drawing time, and all the features that you want to add, you can add in this project. We finished the game, but here is an important update. We released a new version of our SDK. So I will also show you what you need to do to use the updated SDK. So the first thing that we will do is we will update the SDK version. So I will go here, that is dependencies.gradle, and here you can see we are using Stream SDK 4.30.1 beta. So what I will do is I will change it to 5.0.1. After changing the SDK version, we will sync it. Once the sync is done, go to Stream module, and from here we will remove this chat domain, because in our newer SDK this class is removed. So I will remove it from here. We just need chat client now. I will remove the import as well. Now after this we will go to the application class, and here also I will remove this chat domain. I removed the chat domain from here, but I was enabling the offline feature using chat domain. And now if I need to enable the offline feature, then for this I need to use a plugin factory. So here I will define a plugin factory, that is basically offline plugin factory, and I will use stream offline plugin factory. And to this class we need to pass a configuration object. So here I will write config equals to, and I will define config, and it should be from this offline.plugin.configuration package, and it is from stream, as you can see here. So I will use this object, and here we can define some settings. For example, I want the background sync, so background sync enabled is true, and then I can use user presence is true, and then persisted enabled is also true. And we can also define network type for upload attachment. So here I can write upload attachment network type, and it is equals to upload attachment network types, let's say unmetered. So you can define configurations here, and the next parameter we need to pass context. So you can see I need to pass app context, so I can write app context equals to this. App context is like this. So we have our offline plugin factory. Now I will assign this plugin factory to our chat client builder. So here I will write dot with plugin, and I will pass my plugin that I just defined here. Now after this we will go to our main view models. So let's go to main view model, and here you can see I have an error inside this join game group function, and it is because some properties of the SDK in version 5 has changed. And now if you want to add a member to a channel, you need to pass a list and not just the user ID, so that you can also add multiple members at once. So here instead of user ID I will pass list of and then user ID like this, and you can see the error is gone. And that's it. That's all you need to do to update the SDK version. Now if I run the application again, it should work. So we have some compilation error here, and I forget to remove the chat domain from app module, and it is inside import, so I will remove it from here, and that's it. Let's try again. So you can see it is working absolutely fine, and I will push the updated code as well to a different branch so that you can see the differences. So finally we completed our multiplayer game using Stream SDK, and I hope you liked this project. In case you have any problem or question or confusion, you can leave it in the comments below and I will try to help you out. And I hope you found this video helpful and learned something. In case you did, please hit on that like button, subscribe to this channel if you're not already a subscriber, and share this video with all your friends. And I will see you in the next one. Bye bye.